Welcome to the Basics series. One fundamental part of learning the most basic electronic circuit analysis involves the voltage divider rule. Most textbooks explain this as a circuit with two resistors in series with the output not connected to anything. Many circuit applications will have the output going to an input of an opamp, voltage comparator, or some other circuit with an input impedance that is so high that the effect of loading on it is completely negligible. However, this is not always the case. This video will derive the math of a voltage divider output with a load that is not negligible. I've also included a link to a spreadsheet to do the calculation and return the resultant output voltage based on the standard resistor values and its associated error. Let's begin with the classic textbook unloaded voltage divider and derive its equation. The current I through the divider from Ohm's law is Vn over the sum of Ra and Rb. We can say that Vout is equal to the current I times Rb. Substituting the equation for I gives us the standard textbook equation for the voltage divider. Here is the voltage divider with a load resistor RL. Resistors in parallel are equal to the sum of their conductances, which is the reciprocal of their resistances. Combining terms with a common denominator gives us this. Then the reciprocal gives us this classic equation for two resistors in parallel. Now we can replace Rb in the voltage divider equation with the equation for Rb in parallel with RL. To simplify, multiply the numerator and denominator by Rb plus RL, and distribute Ra in the denominator. Divide the numerator and denominator by Rb. In most cases, we know what the load resistance is, so we are better suited with an equation for Rb. Then we need to rearrange to solve for Rb. To reduce the number of terms of RL, multiply the numerator and denominator by RL. Then rearrange to solve for Rb. The first thing to do is to decide what the current in the divider will be. This will depend on the impedance of the source and how stiff you want the divider to be against the load. Then calculate the value of Ra, which is Vout minus Vn over the divider current. Here's the spreadsheet for the calculation of the loaded voltage divider. The inputs are input voltage. I've set the data validation so the input must be greater than the output. If you haven't seen my video on foolproofing Excel engineering workbooks, go check it out. The data validation for Vout must be greater than 0 and less than Vn. The next input is the divider current, which must also be greater than 0. Then the load resistance, which must also be greater than 0. The last input is a pull-down selector for the desired resistor series. The calculation of Ra is inside the E-series function to return a standard resistor value. It uses the selected resistor series value as the argument for the series. If you haven't seen my video on closest E-series preferred number user-defined function, check it out. The calculation for Rb is also within the E-series function. The resultant output voltage is calculated and the error is calculated based on the standard resistor selection. You will find that tweaking the divider current ever so slightly will affect this accuracy. The workbook is protected but requires no password to unprotect. You may want to hide columns for the resistor selection lookup table and the cells that generate the component labels in the schematic. Thanks for watching. Please click the like, subscribe, and notification bell so you don't miss any upcoming content.